Hello everyone and welcome to another video. What is Node.js? Very simple question, but I guarantee you will hear this question in your interviews when you look for jobs. What is Node.js? Is Node.js multi-threaded, single-threaded? What is libuv? Can you answer these questions? Well, being able to answer these simple yet not easy questions will make you write better code and more performant Node.js applications. In this video, we will not only answer these questions, but I will show you in real code how all the internals of Node.js work together in order to create performant applications. So let's get started. Okay, my friends, in order to start discussing what Node.js really is, we need to start the story from the beginning, which is JavaScript. JavaScript is a single-threaded language. What does that mean? That means that when we write any JavaScript code or Node.js application, because Node.js is also JavaScript. So when we write any JavaScript code or Node.js application, we create something called a process in our operating system. So if I go to Task Manager, okay, and if I open Task Manager, you can see I have multiple processes running. For example, I'm running browser, I'm running Camtasia, which is the screen recorder I'm using. We are running Google Chrome. We have multiple processes. Okay, so when we run Node.js application, we actually run a process on our system, on our Task Manager. And inside this process, okay, this process that you see inside this box, inside this process, there is something called a thread, okay? And every process might have one thread or two threads, three threads, multiple threads. But in order to support multiple threads for the single process, the code that executes that application, okay, must support multi-threading. For example, in case of Java, the language Java applications can use multiple threads. But in case of JavaScript and Node.js, they are written in JavaScript. So in JavaScript, there is only a single thread inside our process. What does that mean? It means that the single thread, every thread, is handled by a single CPU core in order to execute its code, its functionalities. So if inside this thread we have something also called a stack. Okay, every thread has code and stack. So the stack, the job of the stack is to keep track of all the code, all the functionalities that we want to execute for our application. So suppose that we have this JavaScript or Node.js application, and inside this application we have these operations. 4 plus 2, we want to calculate 4 plus 2, which is 6, and 6 multiplied by 4, and then filter users. We have this function filter users. So in the case of JavaScript, every operation or every function on this stack will be handled by the operating system by a single CPU core. So once the CPU core finishes acting on this 4 plus 2, it moves to execute 6 multiplied by 4. And then it goes on to the next step, which is filtering users using this function. So it moves one by one using a single core. So that is what it means that JavaScript is single-threaded language. So let's look at another diagram, which is what kind of operations we can run inside Node.js or JavaScript applications. In case of JavaScript and Node.js, we can run something called synchronous operations. But what are synchronous operations? What do I mean by synchronous? Synchronous means that the code or the operation or the function that I'm running is executed in real time right now. And we have something, as I told you, we have the stack. Okay, inside the stack, we have these functions like 4 plus 2 or 6 multiplied by 4. These operations can be handled instantly. The code runs line by line. Okay, the synchronous operations are run line by line. So it finishes 4 plus 2 and then finishes 6 multiplied by 4. So how does the JavaScript executes these synchronous operations or these line-by-line operations? It executes them using something called V8 engine. Okay, V8 engine is the engine that runs Google Chrome. Okay, inside our browser, we run JavaScript inside our browser, right? So using V8 engine. The Node.js uses V8 engine in order to execute operations like 4 plus 2 or 6 multiplied by 4. But what if we have, for example, if we have some function that its job is to read, okay, CSV file, okay, or probably in another function that its job is to call a machine learning algorithm. Okay, somewhere on the internet we have machine learning algorithm hosted somewhere on the internet, and we want to use it using some API. So in this case, we don't deal with synchronous operations, because supposing that these operations happen synchronously, we will need forever. We will need be waiting forever in order for these operations to execute. So they are not executed synchronously, like line by line. We are not reading first the CSV file and wait for every line to be parsed, and in order to call the machine learning algorithm, which might take, for example, 5 seconds in order to do its job. So it's gonna be hell if everything is handled by this single thread, and this single thread is handled by a single CPU core. It's gonna be hell. So in order to solve this problem, so JavaScript has to find a way in order to execute asynchronous operations. Asynchronous operations like API calls, reading from the hard drive, writing on the hard drive, something like that. So what kind of operations or asynchronous operations can be handled by Node.js? So we have different options. The first one is called timers. Okay, we have timers. Timers are functions like set timeout or set intervals. And we have also network callbacks. Network callbacks like HTTP calls or HTTPS calls, or opening a port like listening on port 3000. All these are asynchronous operations handled by Node.js. And we have also file system operations, okay, I/O operations, like reading from the hard drive, writing on the hard drive. So all these operations happen asynchronously, okay, using asynchronous operations. But as we talked already, V8 engine is not enough in order to execute these functions. Okay, so we need to find a way in order to execute all of this, and the way is using something called event loop. So the job of the event loop is to look at all the asynchronous operations that we have running on our main stack or main thread. Okay, it looks at these functions and all these code that we have, and its job is to not execute them. Its job is to order where these functions will be executed. For example, we look at our code. We have asynchronous code. Okay, supposing now that we have only asynchronous code. So the event loop looks at the asynchronous code that we have inside our stack or inside our thread, which is our application, by the way, and it sees the set timeout. Okay, when it sees any timer like set timeout or set interval or set intermediate, when it sees any of these, it says, yeah, let's execute them inside the main stack, because the main stack can execute this. And then it looks again, if it sees any network callbacks like making HTTP calls or listening on port 3000 or something like that, when it sees network operations, the Node.js or the main stack cannot execute a network operations. Okay, it doesn't have this functionality, so it must delegate this functionality to somewhere else. Okay, we will find in a little bit where it will handle all of these functions. So same thing with when it comes to file system operations, like reading from a hard drive or writing on a hard drive, or reading streams like CSV files. In this case, the functions are not also executed on the main stack or the main thread of the Node.js or JavaScript application. It's not executed in the main thread. It must be handled by someone else. Okay, it must be delegated externally. Okay, so in order to achieve this, the creator of Node.js, who is Ryan Dahl, made a very smart decision. Very smart decision. Let me show you. So in 2009, Ryan Dahl created Node.js, and he decided that since JavaScript is a single-threaded language, that doesn't mean that we are limited to the functionalities of Node.js. Let's take advantage of the functionalities of other things that we have on our system. So he said that when it comes to network callbacks, when it comes to network operations, instead of using the main stack, okay, since main stack cannot execute this, let's find a creative solution. And the creative solution is that the network callbacks, like listening on port or making HTTP calls or API calls, for this purpose, we use the operating system, because the operating system is already have all the cores on our CPU. So in modern computers, we have different CPU cores, and every core can handle multiple threads. Okay, it's called multi-threading. That's a property of the CPU. All modern CPUs now support multi-threading. So we can take advantage of the operating system and use its own capabilities in order to make HTTP calls or make all the network callbacks or network operations. So very, very smart move. And also he said that when it comes to file system operations, like reading from CSV file or reading or writing on the hard drive, in this case, we will not use the operating system or the network card. We will use a package written in C++ called libuv. Okay, libuv is a separate package. It's in a project on GitHub you can look at. It's a separate project, and we will use this package or this library in order to execute asynchronous operations when it comes to reading from hard drive or writing on the hard drive or any dealing with the file system. So the purpose of this is because inside libuv we have something called a thread pool. Okay, pool means that multiple things happening inside. So we have thread pool, we have different pools are inside this pool. So we have thread 1, thread 2, 3, and 4. There are 4 pools. There are 4 threads inside the pool. By default, there are 4. So for all these operations, we will delegate them to the thread pool inside libuv, and by that way, we achieve the asynchronous operations successfully inside Node.js. So that's the purpose of event loop. It looks at all the stack, all the operations that are running on our stack, and it says if it was set timeout or set intervals, yeah, let's execute them inside the main stack. If it was network operation, let's do them inside the operating system. If it was file system, let's do them inside this libuv thing. So to have a complete picture of what is Node.js, okay, what is Node.js? This is Node.js, okay? So inside Node.js, we have this diagram. I think now the diagram speaks of itself. I spent some time in order to create it, so I think it's worth it. So we have this JavaScript code or Node.js code, and we are running this JavaScript using Node.js by running this command node index.js. Okay, and by running node index.js, what happens is that if the code was synchronous code, we saw that it is run by V8 engine. But what if it was asynchronous code? Okay, in the case of asynchronous code, we follow this arrow. So this arrow leads us to the event loop, and the event loop handles the asynchronous code, as we talked already. So if the event loop sees any set timeout or any timer, it executed inside the main thread. And if it was some network operation, like in this case, I executed using the network card or the operating system. Okay, like we are using taking advantage of the operating system. But if the asynchronous code was using file system operations like reading and writing on hard drive, we use the thread pool, which happens to be inside this libuv thing. So that is the complete picture of Node.js and what it is, what is event loop, and now you can answer if it was multi-threaded or single-threaded. Yeah, it is single-threaded, but that doesn't mean its functionalities or capabilities are limited to single-threaded operations. And to show you how all these internals, okay, how these internals work together inside a real application, I want to open VS Code on my system. Okay, you can see I have VS Code running. So I have this very simple index.js. You can ignore all these files running here inside this folder and just focus on this index.js. So inside this index.js, we have, first of all, we have this Express. I imported Express and then imported Axios, and then created two operations, three operations, by the way. We have set timeout. Okay, we said already that any timer, for timers, they are running inside the main thread. Okay, and here for this call, okay, I created a HTTP call to this API. Okay, to fetch some user from the internet using Axios. Axios is a library that allows you to make HTTP calls. So I made a HTTP call to this one and fetch some data, and I want to console log this data. Okay, so this operation, as we talked already, is handled by the network card on our system, on our operating system. So handled by the operating system. Okay, what about listening to port 3000? It's also handled by operating system. So now let's see what happens if I run node index.js. Okay, I will click enter, and the moment I click enter, I want to go to this localhost. Okay, I want to go to localhost and click on refresh. Okay, the moment where is the code? That's the code. So the moment I click enter and run this process, this Node.js process, I want to go on this browser and click on refresh in order to refresh the page and see what happens. Okay, and I expect to see some logs. Okay, because I console logged the data and I console logged this string. 7 seconds passed. Okay, because we are waiting for 7 seconds in order to execute this set timeout. Anyway, let's go. 1, 2, 3. Okay, I click refresh. If I go back, you can see the data is coming from the API. And after 7 seconds, I received this console log. What does that mean? Okay, let's analyze what's happening behind the scenes. So if I go back to this diagram, where is it? Okay, this one. Okay, let's make here another block, which is HTTP call. Okay, we have also set timeout. If you remember, set timeout. Okay, if we have only this structure for Node.js, if Node.js was built only with a single-threaded language, like in this case, we have HTTP call and we have set timeout, and this set timeout takes 7 seconds. Okay, it takes 7 seconds to execute. Let's change the order. Okay, let's suppose that this set timeout takes 7 seconds to execute, just like in our case here. It takes 7 seconds. So if this operation was handled by this single CPU core, then we need to wait 7 seconds in order to execute the HTTP call. Okay, we have to wait 7 seconds, and after that we can make the HTTP call. But in our case, you saw that the HTTP call was executed first, okay, by the operating system, and then the set timeout was executed, and we see 7 seconds passed. So 7 seconds passed, but we didn't wait for 7 seconds to pass until we see the data. We already saw the data before the 7 seconds passed. So that is the power of Node.js, and that's why it's super powerful, because it uses the internals of our system. It uses the operating system network card, and it also uses a package called libuv in order to take care of the file system operations which happen in the asynchronous fashion. Okay, so that is the power of Node.js, but there is a problem. What if this call, okay, this HTTP call, takes 7 seconds or 10 seconds to execute. And we have different calls. We don't have a single call in our application, right? And we have different calls to different APIs, or maybe different users are using our application. So supposing that this one will take 7 seconds to execute, then will the application stop for 7 seconds? Yeah, if you are writing code like this, it will hang for 7 seconds until you execute the second line of code and second HTTP call. That's why it's very important to understand these internals in order to start writing some performant applications. In order to write performant Node.js applications, you must understand these basic and fundamental concepts behind Node.js and how it is written and why Node.js is so powerful. Why do we use Node.js and how it executes asynchronous code? So if you are interested in learning how to write performant Node.js applications, make sure to subscribe to my channel, because in the next weeks, I will share content on how to write performant Node.js applications. And I don't want you to miss this content, because it's very, very powerful for your career, for your future career. Even if you have just started working with Node.js, it's totally fine. It's all beginner friendly. And that's all I have for now. I hope you enjoyed the video, and if you did, please consider clicking on the like button below and subscribing to my channel to get notified about more videos like this in the future, and also to support my channel and the YouTube algorithm. And until then, take care of yourselves and see you very soon.